This is Calculus 1 video lecture number 7 on derivatives and rates of change. We're going to go back to the tangent and velocity problems that we discussed earlier when we began this Calculus 1 video lecture series and look at tangent lines to begin with. So remember, we have some function f of x and we're trying to figure out what the slope is of the tangent line to this curve at some point P. So P is shown here, and I want to know what the slope of the tangent line is to the curve at that point. So the tangent line would look something like this. And remember, we have a point, but we have no way just yet of finding the slope of that tangent line. So what we did was we drew a secant line that went through the points P and Q. The secant line is shown here in blue. And we used the slope of that secant line to help us approximate the slope of the tangent line. So the slope of the secant line, or the line that goes through P and Q, was found by taking f of x minus f of a divided by x minus a. That's because the point P has coordinates a, f of a, that's fixed, and then Q has coordinates x, f of x. It's some other point on the curve. So then the slope of PQ, you can see we find it by taking the difference in the y coordinates, f of x minus f of a, and then divide by the difference in the x coordinates, x minus a. And that's where we get that expression. Now, if we move that point Q, which we discussed before, closer and closer to this point P, then the slope of the secant line approaches the slope of the tangent line. And if we find that limit, the limit as Q approaches P of MPQ, then it equals M, which is the slope of the tangent line at P. And another way to state this is the following, now that we know limit notation. If we take the point Q and approach the point P, that's the same as saying X approaches A. So the limit as x approaches a of f of x minus f of a divided by x minus a is equal to m. This m is m tangent. All right. Good. So again, the idea is x approaches a, and the slope of the secant line approaches the slope of the tangent line. Now, you could relabel this picture a little differently and get another version of this slope formula right here. Okay, so I want to show you where they both come from. Here's the slope formula, one version of it. Now we're going to look at this picture, which is labeled a little differently. So same function, f of x. Again, we have the point P here with coordinates a, f of a. And then now I'm going to move a distance h in the x direction. So now here, the x coordinate is a plus h. So notice Q has coordinates a plus h, f of a plus h. So let's figure out how we would express the slope of the secant line first. Okay, so MPQ would be change in the y coordinates. So f of a plus h minus f of a divided by change in the x coordinates, so that would be a plus h minus a. And this gives us f of a plus h minus f of a all over h. Well, that's the slope of the secant line. How do I get the slope of the tangent line? Well, I need to make that difference between the 2 points, which is given by the distance h, approach 0. So to get the slope of the tangent line, I need to take the limit now as h approaches 0 of f of a plus h minus f of a all over h. Have you seen this expression before, just without the limit portion? You should have at some point in your pre-calculus studies. This is the difference quotient. Okay, and you should have seen that it represents the average rate of change, And then when you add that limit to the front, then that makes it an instantaneous rate of change. All right, so let's see how we're going to apply it. First example, find an equation of the tangent line to the curve y equals 2x cubed minus 5x at the point negative 1, 3. Okay, so this is basically f of a. This is the point P. And then when we're writing the equation of any line, we need two things. We need, first of all, a point, and second of all, a slope. Well, I have a point. They gave me that. The point is at negative 1, 3. Done. The slope, though, I don't have. And they only gave me 1 point. And remember, I need the equation of the tangent line. So what we're going to use is the limit definition we just considered on the previous page. So remember, a is equal to negative 1. And the slope of the tangent line is equal to the limit as x approaches a. So as x approaches negative 1 of f of x minus f of a, in this case negative 1, divided by x minus negative 1. This is one version you can use. So let's see here. This is going to give us the limit as x approaches negative 1. In the numerator, I'm going to put f of x in, so that's 2x cubed minus 5x minus f of negative 1. That's the y value. When x is negative 1, they gave me that. It's 3 divided by x plus 1. All right, this limit I won't ever be able to evaluate using direct substitution because you're going to get 0 over 0. So I need to factor it. Now it's a little tricky to factor 2x cubed minus 5x minus 3. So one thing we can do is use synthetic division to help us factor. So there's lots of different ways to set up synthetic division. I'll just show you what I do. We're going to divide by the factor x plus 1. So I'm going to divide using negative 1 here, and then I list the coefficients of the dividend. So 2 for the x cubed term, 0 for x squared, negative 5 for x, and negative 3. That's the constant. And then remember, you just bring down that first term, multiply on the diagonal, and then add vertically, and then just keep repeating the process. So negative 1 times negative 2 is 2. I'm going to add, that's negative 3. Negative 1 times negative 3 is 3, and that's 0. So this represents the coefficients of the quotient, which would be 2x squared minus 2x minus 3. Okay, so I'm going to now rewrite the numerator factored. So we have the limit as x approaches negative 1. Now we have 2x squared minus 2x minus 3 times x plus 1 over x plus 1. Perfect. Now we're in business. So we can cancel out x plus 1. And I'm left with the limit as x approaches negative 1 of 2x squared minus 2x minus 3. Okay, great. Can we find the limit now? Absolutely. Just substitute in negative 1 for x. So we have 2 times negative 1 squared. Now this will be plus 2 minus 3, which equals 1. So that's the slope of my tangent line. And then remember, I already had the point. The point was at negative 1, 3. So we're going to put it all together, write the equation of the tangent line, and let's start off using point slope form. So y minus y1, y minus 3, equals m times x minus x1. So y minus 3 equals x plus 1, which means y equals x plus 4. Very nice. Now I did mention, right, we have two versions of that formula to get the slope of the tangent line. So alternatively, another way that you could get m would be to use the formula that involves h's. So you would find the limit as h approaches 0 of f of, it's a plus h, so negative 1 plus h, minus f of a, f of negative 1, divided by h. And in this case, it would be the limit as h approaches 0 of 2 times negative 1 plus h cubed minus 5 times negative 1 plus h. That is, let me highlight for you. So f of negative 1 plus h, that's right here. Substituting in negative 1 plus h for x. Minus 3, that's f of negative 1, all over h. So in order to evaluate this limit, you wouldn't have to do any factoring, but notice you would just have to do quite a bit of multiplying. You'd have to take negative 1 plus h and cube it. Whereas when you use the formula here, f of x minus f of a over x minus a, that's typically going to require you to do some sort of factoring. So when you're deciding which formula to use, it kind of just depends on the problem, which one you're more comfortable with, and certain functions. One version of the formula for finding the slope of the tangent line will be easier than the other version. So know both, because in some instances, you're going to want to use one over the other. Okay? Good. Let's look at some more examples here, talking about our velocity problem. So suppose an object moves along a straight line according to an equation of motion, s equals f of t. So the object can only move in one dimension, meaning it's only going to move forward and backwards, up and down, but it cannot move in a two-dimensional plane. So if you want to figure out the average velocity, you look at its displacement, its change in position, divided by the change in time. And so we have this formula again for average velocity. F is telling us its position, where it is. It's like a little tracker. It's the little GPS, okay? So if it's on the time interval that starts at A and it ends at A plus H, so think of it this way. It goes from A to A plus H. Then the displacement divided by the time gives you the average velocity. Okay, and this is similar to the formula that we use. Well, it's exactly the same as the formula we use for the slope of the secant line. Now, if you want the instantaneous velocity, this is instantaneous, at one moment in time, then you need to take the limit as h approaches 0 of f of a plus h minus f of a divided by h. This corresponds with the slope of the tangent line. All right. Good. So if you're asked for an average velocity, they need to give you two time values over which you're computing the average velocity. If you're asked for an instantaneous velocity, it needs to be at one specific time value. And alternatively, you could use the other formula for instantaneous velocity. You could take the limit as t approaches a of f of t minus f of a over t minus a. All right, very good. Now, occasionally they'll be asking you for speed. So, as a note, speed is equal to the absolute value of velocity. Why is that? Well, remember, velocity has a magnitude and a direction. Speed just will have the magnitude only. What do we mean by that? So if velocity is negative 30 miles per hour, that not only tells me how fast I'm going, but it tells me that I'm traveling in the negative direction. So the negative tells me which way we're going. The magnitude tells me exactly how fast. Speed is magnitude only. We're not interested in the direction. So that's why you just take the absolute value of the velocity. Good. So let's look at an example here. If a ball is thrown upward, its height after t seconds is equal to 40t minus 16t squared. You could think of this as f of t. So f of t is 40t minus 16t squared. Find the velocity when t equals 3. So which velocity are they asking for? Average or instantaneous? It has to be instantaneous because I'm only finding it at one moment in time. All right, so the instantaneous velocity, and now you can use either formula. Since we used this formula in the last problem, I'm gonna go to the one that involves the h's, okay, for us to work with, just so you're familiar with both. So the instantaneous velocity is gonna be the limit as h approaches 0 of f of, in this case, a is 3. So 3 plus h minus f of 3 all over h. Okay, here we go. So we have the limit as h approaches 0. So f of 3 plus h, I'm going to substitute in 3 plus h for t here. So that's going to give me 40 times 3 plus h minus 16 times 3 plus h squared. That's all of f of 3 plus h minus f of 3. So f of 3 is going to be 40 times 3 minus 16 times 3 squared. And then this is all divided by h. Now, let me highlight for you what happened. So f of 3 plus h, that's right here. And then f of 3 is right here. And everything gets divided by h. Okay, now we're going to multiply everything out. 3 plus h quantity squared, that's 9 plus 6h plus h squared. And then 40 times 3, that's 120 minus 16 times 9 is 144. Great, so we're going to have the limit as h approaches 0. Let's see what's going on in the numerator. So we've got 120 plus 40h. And then now I'm going to distribute the negative 16 to everybody here. So negative 16 times 9, that's negative 144, minus 16 times 6h is 96h, minus 16h squared. And then 120 minus 44 is negative 24, but then I'm subtracting that, so it's going to be positive 24. And I divide all of this by h. Good. Hopefully you remember simplifying the difference quotient from pre-calculus. So from here, everything that doesn't have an h in the numerator should cancel out. So that's going to give me negative 24, which cancels with the positive 24. And we're in good shape because now the next step is I want to factor out h from all the terms that remain in the numerator. So I'm going to take out an h. Let's see what's left over. Notice here I have 40h minus 96h, so that's negative 56h. I just took the h out, so I've got negative 56. And then this is minus 16h squared. I took the h out though, so it's just minus 16h over h. H's cancel. Now we have the limit as h approaches 0. Of negative 56 minus 16h. I can go ahead and substitute in 0 for h, so that's negative 56 minus 16 times 0, which is negative 56 meters per second. Very good. You know, they didn't tell me it was meters, they told me seconds. Look at me assuming. Anyways, so make sure you include the appropriate units. I don't know what unit it is, so I'm going to put units per second. They didn't specifically say it was in meters. Nice. If you feel like you're not comfortable working with the difference quotient, I'm going to link right here a video I made, and it just gives examples of how to simplify the difference quotient for different kinds of functions if you feel like you need more practice with it. All right. Very good. Now we're going to look at derivatives. Now, the above formulas are given a special name. The derivative of a function f at some number a is as follows. F prime of a, that's how you read that out loud. F prime of a equals the limit as h approaches 0 of f of a plus h minus f of a all divided by h. And similarly, you could find the derivative of a function at a number a by using the other version of the formula, f prime of a equals the limit as x approaches a of f of x minus f of a over x minus a. So on a graph, f prime of a is equal to the slope of the tangent line, and it represents the instantaneous rate of change. If you don't write the limit part, it's not correct. You'll lose points, and it also represents something totally different. It represents the average rate of change, not the instantaneous rate of change. And we've seen that when we studied the difference between the slope of the secant line and the slope of the tangent line, and the average speed or average velocity versus the instantaneous velocity. All right, so let us look at an example now. Find f prime of a if f of x equals x squared plus 1 divided by x minus 2. So in this case here, we are given a function. We're allowed to use whichever version of the formula we like, and we're going to find what the derivative is at a, but it's going to be in terms of a. They didn't give me a specific value to plug in. Okay, I'm going to use the first formula here with h. So we're going to take the limit as h approaches 0. Remember, it's f of a plus h. So everywhere that there's an x, I'm going to substitute in a plus h. So I have a plus h squared plus 1 over a plus h minus 2 minus f of a. So just switch the x's out for a's. So a squared plus 1 over a minus 2 all over h. All right, now how to clean up from here? Well, we have a complex fraction, right? You don't want to have a fraction within a fraction. So I'm going to multiply by the LCD of the entire expression. The LCD of the entire expression is going to be a plus h minus 2 times a minus 2. So we're going to multiply by a plus h minus 2 times a minus 2 over a plus h minus 2 times a minus 2. And then this gets distributed, right? So here, let's see. I've got the limit as h approaches 0. We have a plus h squared plus 1 times a minus 2. The a plus h minus 2 is going to cancel out. Good. I think I have too many parentheses. Hold on. And then minus, I have a squared plus 1 times a plus h minus 2. The a minus 2 cancels. And then in the denominator, we just have h times a plus h minus 2 times a minus 2. Very good. So now we just got to multiply everything out. So we have the limit as h approaches 0. A plus h squared, that's a squared plus 2ah plus h squared plus 1. I'm going to multiply that by a minus 2 minus, and then now let's multiply out those last two factors. This is going to be a cubed plus a squared h minus 2a squared plus a plus h minus 2. And don't multiply out the denominator. Don't do it. So we have h times a plus h minus 2 times a minus 2. You want to keep the denominator factored. Okay, a little more multiplying in the numerator, and then we get to have our little cancel party. So distributing out a squared, we're going to have a cubed plus 2a squared h plus ah squared plus a minus 2a squared minus 4ah minus 2h squared minus 2, and then let me distribute the negative while I'm at it, minus a cubed minus a squared h plus 2a squared minus a minus h plus 2, all over h times a plus h minus 2 times a minus 2. Okay, now we get to have a cancel party. Remember, all the terms that don't have h in them should cancel out. So here's a cubed. I better find, yep, there he is, negative a cubed. Who else doesn't have an h? Let's see here. A. Do I have a negative a? Yep, I do. What else? Negative 2, that's going to cancel with positive 2. Anybody else? I don't think so. So we've got the limit as h approaches 0. Now let's combine our like terms. So 2a squared h. Do you see another a squared h? I do, right here. So that means I have 1a squared h. Who's next? AH squared. Is there another one? Nope. So plus AH squared. Oh, look, negative 2a squared. That should cancel with the positive 2a squared. Good, we got them. Who's next? Negative 4ah. Is there another one? No. So negative 4ah. What else? Negative 2h squared. That's the only one. Who am I forgetting? Yes, don't worry. Here's negative h. Okay, everyone's accounted for. Over h times a plus h minus 2 times a minus 2. Okay, good. Remember, everything without an h needs to cancel because the next step is the key to evaluating the limit. You're going to factor h out of everybody in the numerator. So we have the limit as h approaches 0. Take that h out, and now I have a squared plus ah minus 4a minus 2h minus 1 all over h times a plus h minus 2 times a minus 2. So this is why you don't want to multiply out the denominator. Look, now I can cancel these h's so nicely. And I can go ahead and evaluate the limit using direct substitution. I'm just going to plug in 0 everywhere I have h. Okay, so this limit is going to be a squared plus a times 0 minus 4a minus 2 times 0 minus 1 over a plus 0 minus 2 times a minus 2. Notice I didn't write lim anymore because I've already plugged in 0 for h. And then let's see, what are we left with in the numerator? I've got a squared minus 4a minus 1 over the quantity a minus 2 squared. And now we are done. Okay. Now, it's easy to get overwhelmed, but just as long as you work neatly, don't skip too many steps unless you're comfortable doing it, because that's when students tend to make mistakes, and just keep track of everything. Okay, you're in calculus by now, so you should be able to just handle some foiling and multiplying. Just stay on top of things. Okay, one last example. Here we have f of t, which is equal to t to the negative first minus t, and they're asking us to find the velocity and speed when t equals 5. Again, this is going to be the instantaneous velocity because we're only given one value in time. All right, we have our choice. We could either use the limit as h approaches 0 of f of 5 plus h minus f of 5 over h, or we could take the limit as t approaches 5 of f of t minus f of 5 over t minus 5. And in this case for the function, either one will probably be just as much work. So it's up to you. Since we've been working with the formula that involves h's a lot lately, I'll switch it up this time. Okay, and just to remind you, f of t, if it's t to the negative first, that's the same as 1 over t minus t. Okay, so I'll use this formula for this example, but see if you can work it out using the other version as well. Here we go. So we have the limit as t approaches 5. F of t, you just rewrite the function as is, 1 over t minus t, minus f of 5, that's going to be 1/5 minus 5, all over t minus 5. Now we're going to start off using the same approach. I want to clear out, this is a complex fraction, right? We have a fraction within a fraction. So I'm going to multiply by the LCD of the entire expression to clear out the fractions. So we've got 5t as our LCD. you just look at the denominators, right? And say, if I were to add them together, but I'm not going to, what would the common denominator be? All right, so now back to the limit. I'm going to take the limit as t approaches 5. And remember, this 5t is getting multiplied by every single term here. So 5t times 1 over t, that's just going to be 5. Minus 5t times t, that's 5t squared. Minus 5t times 1/5 is going to be t. And then plus the last term, nothing cancels, 25t. And then in the denominator, I have t minus 5 times 5t. Don't multiply it out. Good. I notice I can combine like terms in the numerator. So I have the limit as t approaches 5 of negative 5t squared plus 24t plus 5 over, let's put the 5t first. Doesn't it look so weird at the end there? Good. Now, when I use this version of the formula, usually I have to try to figure out how to factor. And it's always a good idea, if there's a negative in front of that leading term, to factor it out. It'll make life a lot easier instead of trying to factor with it. So negative 5t squared minus 24t minus 5 over 5t times t minus 5. Now you guys tell me, can you factor this trinomial? I certainly hope so. So this is the limit as t approaches 5. We've got negative 5t plus 1 times t minus 5 over 5t times t minus 5. And lo and behold, I can cancel out t minus 5 now and go ahead and use direct substitution to evaluate this limit. I'm just going to plug in 5 for t. So I have negative 5 times 5 plus 1 over 5 times 5. So in the numerator, we're going to have a negative 26 over 25. And it's at 5 seconds. I don't know what sort of unit the distance it's being measured in. So I'll just say units per second. That's the velocity. So the velocity is negative 26 over 25 units per second. And then the speed, remember, they asked for that, is the absolute value of the velocity. So that would just be positive 26 over 25 units per second as well. And that's our final answer. So that concludes the lesson. If you need help with factoring as well, don't be ashamed. I'll link up here some of my factoring videos. But be sure to take your time with this. This section is just computationally a little more demanding than the previous lessons, but it's nothing beyond what you can handle. Okay? So don't forget to give this video a thumbs up, subscribe if you haven't already, and stay tuned. We have one more section to cover about the derivative.